The roar of a jet engine, propelling aircraft across the skies at incredible speeds, is a testament to human ingenuity. This revolutionary technology, born in the early 20th century, has reshaped travel, trade, and even warfare. Before the advent of jet engines, piston-powered aircraft dominated the skies, but their limitations were becoming increasingly apparent. Jet engines promised greater power, efficiency, and the ability to reach far greater altitudes and speeds, ushering in a new era of aviation. The first successful jet engine, the Heinkel HES-3, took to the skies in 1939, marking a pivotal moment in aviation history. Developed by Hans von Ohain in Germany, it paved the way for a new generation of aircraft. Shortly thereafter, Sir Frank Whittle, working independently in England, developed his own jet engine design, the Powerjets WU. These pioneering inventions ignited a technological race, with engineers and scientists around the world striving to perfect this powerful new form of propulsion. The jet engine's impact was immediate and profound. World War II witnessed the emergence of the first jet-powered fighter aircraft, like the German Messerschmitt Me 262 and the British Gloster Meteor, forever altering the landscape of aerial combat. Following the war, jet propulsion rapidly transitioned from military applications to civilian aviation. The de Havilland Comet, introduced in 1952, became the world's first commercial jet airliner, marking the dawn of high-speed, long-distance air travel for the masses. At the heart of a jet engine lies a simple yet elegant principle: Newton's third law of motion. This fundamental law states that for every action, there is an equal and opposite reaction. In the context of a jet engine, this means that the expulsion of a high-speed jet of gas in one direction creates a thrust force in the opposite direction, propelling the aircraft forward. To achieve this, a jet engine draws in a large volume of air at the front, compresses it to increase its pressure and temperature, mixes it with fuel, and ignites the mixture in a combustion chamber. The resulting hot, expanding gases are then forced through a turbine, which extracts energy to power the compressor at the front of the engine. Finally, the high-velocity exhaust gases are expelled out the back of the engine through a nozzle, generating thrust. This continuous cycle of air intake, compression, combustion, and exhaust creates the powerful thrust that propels jet-powered aircraft. The efficiency of this process is directly related to the velocity of the exhaust gases. The faster the gases are expelled, the greater the thrust generated. Jet engines excel in this regard, capable of producing high exhaust velocities, making them ideal for achieving high speeds and altitudes. A jet engine, while based on a simple principle, is a complex and meticulously engineered piece of machinery. It comprises several key components that work together seamlessly to generate thrust. Understanding the role of each component is crucial to grasping the intricacies of jet propulsion. At the front of the engine lies the fan, responsible for drawing in massive amounts of air. The fan blades are designed to accelerate the incoming air, increasing its pressure and directing it towards the compressor. The compressor, consisting of multiple stages of rotating and stationary blades, further compresses the air, raising its temperature and pressure significantly. The compressed air then enters the combustion chamber, where it mixes with fuel and ignites. The combustion process releases a tremendous amount of energy, heating the air to extremely high temperatures. The hot, expanding gases then flow through the turbine, which acts like a windmill, extracting energy from the gas flow to power the compressor at the front of the engine. Finally, the high-velocity exhaust gases exit the engine through the nozzle, generating thrust. The nozzle is carefully shaped to accelerate the exhaust gases to their maximum velocity, maximizing the thrust produced. The interplay of these components, working in perfect synchronization, underpins the extraordinary power and efficiency of jet engines.